Okay, this is number 64, so this is part 4. Getting ready for the final. We're going to do some more work with the exponents and then get into quadratics again with completing the square. Okay, so here you can see we have a power to a power. So we haven't had this in our review yet where we're raising an exponent to an exponent. So once again, the long way that always, not always, but you know, is very accurate. If you want to make sure you're doing everything right, you're not sure whether you should multiply or add exponents, just show everything. So you just write it all out. Right? So to the third power means, you know, times itself 3 times. Right? And then you can see here, like, oh, it's negative 2 times negative 2 times negative 2. That's negative 8. Right? And you can go, well, 4x's, 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 all together, that's 12. Okay, and likewise for the y's, 6, 6, and 6 make 18. Okay, so just writing out like that might be a little easier than over here. You might be thinking, well, should I add those two and get 9? Here I get 7, and then maybe should I do that to the number 2? You know, it's like it gets a little confusing. So I always recommend for these, when you have a power to a power, just write it out. It doesn't take very long, and you get a very accurate answer. All right, number 2. Okay, we got negative exponents. So remember, that just moves them from top to bottom or bottom to top. So the x's will move down, and these negatives right here will move to the top. So we just got things moving around first. Let me rewrite everything. Not change anything, but just move. Okay, so we have the x's. There's already an x to the 9th. So now I also have an x to the positive 5. And already had a y to the 4th. And now I have another y to the 2nd. So I just moved the negative stuff first. Left this negative alone. That's a completely different negative altogether. It looks like the same exact symbol, right? But they actually mean different things when they're an exponent or if they're a coefficient. All right, so let's just reduce here. Okay. 5 over, looks like divided by 2, so 5 over 6. We'll have negative 5 over 6. Right? And on top we have 4 y's and 2 y's. So altogether we have 6. And on the bottom we have 9 x's and 5 x's. So we have 14. There we go. Fully reduced and simplified. Going down here, we'll have 25, and we're going to break it up into 2 parts. So I'm going to take it to the half power, which is the same as the square root. Right? So square root of 25 is just 5, and then 5 to the third power is 5 times 5 times 5, right, which is 125. Number 4, got some more radicals. So we can divide these by 3, right? But, well, 12 we can divide by 3, but 4 we can't. So we got some issues because we know we're just supposed to divide these exponents, right? But 3 doesn't go into 4. So what we're going to do is break this up into 2 parts. A part that I can take the cube root of and a part that I can't. So, for instance here, like the x to the 12th, I can divide 12 by 3, or whatever's out here. So I'm going to put that on this side. Now the 4, I can't divide 3 into 4, but I could divide 3 into 3, and I'll just have an extra y over here to make 4. So you see I'm breaking this part up into 2 parts, something I can divide 3 by, and anything left over here. And the 54 is not a perfect cube. I can't take the cube root of 54, but what you can do is take 54 and break that up into, well, that's going to be 27 times 2. Right? And 27 is a perfect cube. Right? And 2 is not. So I'm going to put it over here. The part I can't take the cube root of, I need to have a cube root there as well. That goes with this. Okay? I cannot take the cube root of any of this, so that's just going to stay exactly the same. But all this stuff, I've set it up now that I can. The cube root of 27 is 3. 12 divided by 3 is just 4. and 3 divided by 3 is just 1. Okay? That's a little more difficult problem, okay? But it's about breaking it up into two parts, something you can take the square root of, cube root of, and something you can't. It's actually very similar to reducing like just a regular radical. So like if it was root 20, we broke it up into two parts then as well, right? Something I can take the square root of and got 2, and something I couldn't, and I just left that alone. This just is our cube roots, and it also has variables at the same time. So it's a lot going on, but the idea for reducing radicals is the same. Break it up into two parts, something you can and something you can't take the square root of. All right, let's go down to solving once again. So let's take care of these coefficients first. Okay, so 54 again, popular number, divided by 2. So we have 3 to what power is 27? Right? And 27 is the same as 3 to the third power. So that way I know that x equals 3. Okay? So it's just asking, really right here, 3 to what power is 27? Well, that's 3 times 3 times 3. So the answer is 3. Number 6, got a little bit more going on, so I'm just going to undo what I can. So start with addition and subtraction like we always do. All right, so that would be negative 75. Divide both sides by negative 3. Right, and we have 75 divided by 3, which is 25. And the negatives cancel out and make positive. So it's just asking you, 5 to what power is 25? And you can probably figure out that that's going to be 2. 5 to the second power is 25. So x equals 2. All right, let's do a few more. Number 7. Oh, completing the square. Okay, so we're going to switch to quadratics. All right, so completing the square. Now this actually involves two parts. Okay, first, you're going to get into vertex form. Okay. Then you're going to solve the vertex form by taking the square root of both sides. So it's actually a little lengthy process. Let me show you on Desmos. Okay, so let's first do a little reminder of what this means, okay, to complete the square and vertex form and everything. So go back to Desmos. Okay, so standard form, okay, that's when we have, let's see here, in this format, right, with ax squared plus bx plus c, and we can manipulate the a, b, and the c, like the a we know makes it move up and down, right, the b changes the direction it's on, right, the side it's on the graph. The c moves the graph up and down, right? So in this format, you can really identify, number one, the two x-intercepts pretty quickly, but also the y-intercept. So I know where the y-intercept is at any time because I know it's equal to c. So that's something nice about the standard form, right? Problem is, I a lot of times want to know what the vertex is as well. And if I start going and moving these things around, I want to know where the vertex is, right? And in standard form, you really can't tell what the vertex is, right? You can see here, it's really good at giving you the y-intercept and the two x-intercepts, but if I want to know where this is, I have to do a lot of extra work. So that's why we have the vertex form, because when it's put into vertex form, right, I always know where that vertex is, right? And it's only two numbers. It's not A, B, and C. It's just two numbers, H and K. So it simplifies it. And yeah, maybe I can't see what the y-intercept is by looking at this formula, or, but I can see what the vertex is, which could be more valuable depending on what you're doing. So that's why we have both. Okay, we have a standard form and a vertex form. And from the vertex form, there's a way to get the two x-intercepts as well. So both of them will give you the x-intercepts, right? And just one gives you a y-intercept for the standard form, but the vertex form gives you the vertex instead, and that's where they differ. Okay, so let's go ahead and practice a little bit of that. Okay. All right, so first thing we want to do, there's a couple ways of doing this. So if you have another way and it might be easier for you or better for you, go ahead and do that. But in class, we always kept these equal to 0 from the beginning. So the first thing I wanted to do is just subtract 10 on both sides, right? Because you've seen everything we've done. It's really equal to 0. Okay. Then give yourself a little space. Set it all up. And we said, oh, we got this minus 10, right? And we said, there we go. We took half of 6, and we get 3, right? Now, by adding this 3 out of nowhere, and it's to the second power, I really just added 9 to this side. So what I want to do is subtract 9 as well. So because this is a plus 9, I want to subtract 9, and it keeps it in balance. So what we end up with is x plus 3 squared, and then these two make negative 19, right? So now I don't know where the y-intercept is by looking at this. We know it's negative 10 because that's where we started. But now I know what the vertex is. It's going to be a negative 3, negative 19. And you might recall that you see how this was positive, that you must change that sign. And now I have the vertex form. Okay. I actually should put that off to the side. Okay, so the first part of completing the square is really getting the vertex form. I'll put that over here instead. And that's the vertex. Okay, now, to actually get the x-intercept, so that's what they're talking about here, completing the square. When they say solve, that always means x-intercepts, right? So here's what we're going to do. We're going to add 19 to both sides. Okay. And then we're going to have this equal to 19. Now we're going to take the square root of both sides. To get rid of this to the second power, we're going to square root it. Okay? So I'll have two answers from this. Okay? I'm going to have, let's see here. Oh, I'm going to do it like this. X plus 3, because the x squared, the square and the square root, in a sense, cancel out, right? But then I'll get two answers, plus or minus square root of 19. And then I can subtract on both sides, and I have my two x-intercepts. So my x-intercepts are going to be negative 3 plus square root of 19, right? And negative 3 minus square root of 19. So there's two answers there. Okay, this is the exact form. Now, if you wanted to, you can type in a calculator and find out what square root of 19 is, right? And you can also approximate it. So if you know square root of 16 equals 4, and square root of 25 equals 5, right? Square root of 19 is kind of close to here, right? So it's going to be around, like, let's say 4.3, maybe 4.2. So if you want to get some approximate answers, we could make this a decimal or just put in a calculator. And you can get your two answers to be like 1.3 and negative 7.3. If we add one of them and then subtract the other, we'll get these two decimals. And that's another reason we really like completing the square, because factoring does not give us decimal answers. As soon as we ran into something we couldn't factor, and that was prime, we kind of gave up and said, well, can't do it that way. But with completing the square, we can actually get those decimal answers. And that's what's one thing we like about it. So there are your two answers solved by completing the square. And you'll get the same exact answer if you use the quadratic formula, which we'll practice in a little bit. Okay, but two ways of getting the same thing. Okay. I know it's a lot. It's going to take a few times going through this and looking at your notes, your tests, and your homework to really remember it, but it does come in handy sometimes. So let's practice another. Do it all the way through. I'll explain less just so you can see it in a more natural speed. Okay. So I'm going to leave a little space. Oh, actually, no. I'm going to set it up first. Let's do it that way. Okay. So we got here, and I got this plus 9. Okay, so just bringing that down, leaving this a little empty here. So half of negative 10 is negative 5. Now I just added negative 5 times negative 5, right? That's 25, so I need to subtract 25 as well. Right, so I have x minus 5 squared, and 9 minus 25 is negative, is that negative 16? Yeah, equals 0. Okay, so now I can solve this in the same way I did before, right? I have my vertex if I want it. So from here I can see the vertex is 5 comma negative 16, okay, positive 5, so I change the sign. Right, so that's my vertex if I want it. Okay. Now we can also solve it. So I'm going to add 16 to both sides. This will be a little easier. Last time we had 19, and we could not take the square root of 10, right? But now we have 16. That you can take the square root of, so this one's actually a little easier. So square root of 16, we'll get, again, don't forget, plus or minus 4. Square root of 16 is 4, but we get 2 answers. Okay. And if I add 5 to both sides, I'll have my 2 answers. X is going to be 5 plus 4, and then also 5 minus 4. So I'll get 9 and 1 as my x-intercepts. So those are my 2 answers if I solved it. All right. So again, takes a little review, a little practice doing this. It's much easier when you have a nice perfect square that you can take the square root of. Like here, square root of 16 was 4. Here we got 19, so we had to approximate and get 4.3. So it just depends. Okay, let's find the discriminant. All right, what is the discriminant? Let's review that. So let's go back to here, pull up discriminant. Okay, open this one. So real quick, discriminant was just a little part of a quadratic formula, that b squared minus 4ac. Okay. And what happened is that if the discriminant, as you can see here, is positive, I can get this to, yeah. If the discriminant was positive, you can see it's 14, we had 2 answers. So you can see there's 2 different answers. It's crossing at 2 places. So anytime the discriminant was positive, meant we have 2 answers. But when we got close to 0 and got to 0, you can see it only crosses the x-axis at 1 place. Right? And as soon as that discriminant became negative, there were no solutions at all. It did not cross the x-axis whatsoever. So this discriminant, this one number, could tell us if the answer was 0 solutions, like here, no solutions, no real solutions. If it had 1 solution, like right here, when it equaled 0, or 2 solutions when it was a positive number. So without doing all the work, if we just want to know if there's an answer or how many answers, we could just save ourselves some time and just calculate the discriminant and look at the sign of the answer, not really the number. The number didn't really matter. If we got 20 or we got, 10, it still meant 2 answers. The fact that it's a positive number that meant 2 answers. And 0 meant 1 answer, and negative number, since this goes in a square root in the formula, quadratic formula, you can't take the square root of negative, so you don't get an answer here. Okay. So that was the discriminant, only to be used when we want to find out how many answers there are. 0 solutions, 1 solution, or 2 solutions are the possible answers. Okay, so again, if you want to, you can always write it down. D is just b squared minus 4ac. Right, so the discriminant here, this is a, negative 2 for b, negative 5 for c. Don't forget those negative signs. Those are part of the number. So my discriminant will be negative 2 squared minus 4 times a times c. So a is 3 and c is negative 5. Again, I'm looking to see if I get a negative answer, right? I know there's no solutions, no real solutions anyway. If I get an answer of 0, I know that there's 1 answer, 1 solution. And if I get a positive answer here, I know that there's 2 solutions, 2 x-intercepts. So I'm really just looking to find the sign of the answer. The number is not too important at this point. So I get 4, and then I'll have negative 4 times 3 times 5. That's going to be plus 60, I think. Yep, plus 60. So we get a positive number so I know that there are two solutions here. And again, it's 64. I really don't care that it's 64. It's the fact that it's a positive number, right? So I get two solutions, right? If we want to be talk about the type of solutions, right, that's when we get into 64. I can take the square root of 64, so I'll get two rational solutions. Okay. What you'll see on your graph, rational just means it'll be a whole number. It's not non-decimal, is a way of looking at that. Non-decimal, or at least long decimal. Okay. Some easy numbers to work with. If this was like 60, yeah, if you put in the square root of 60 in the calculator, you'll get this long irrational number. Okay, so let's practice a little bit more. So again, identify A, it's -2, B is 6, and C is 1. Go ahead and calculate it. So we got B squared, 6 to the second power, minus 4, A, and C. So we got 36 plus 8, which is a positive number. So because it's a positive number, again, going to have two solutions. Now this time, if we add those up, right, we'll get 44. And if you try to take square root of 44, you will get some long decimal. It'll be something like 6 point, and it'll keep on going forever. So those are two irrational solutions. So that decimal just keeps on going forever and ever. Two irrational solutions. Okay. And, there's where the answers go, actually, down here. And then I guess they want us to find these solutions. State the type. I guess that should be the directions. That always helps. And then solve by using the quadratic formula. Okay, so then we can solve by using the quadratic formula. So remember, that is negative b plus or minus the square root of b squared minus 4ac. All over 2a. That's the quadratic formula. Now, we just did this right here. So we just took a shortcut, really. We already did part of the work. So we just really need to plug in our b and our a here into the formula. So we'll get negative of -2, b is -2, plus or minus square root of 64, all over 2 times a, which a was equal to 3. Okay, and do a little simplifying, so I'll get positive 2, right? Negative times negative, plus or minus 8 over 6, right? And then we'll get our two answers, so we get 2 plus 8 divided by 6. Okay, that's 10 over 6, which is 5 over 2, or 5 over 3. There we go. And then over here we'll get 2 minus 8 over 6. So that's going to be -6 over 6, which equals -1. So there's our two rationals. You can see they're just fraction and integer, non-long decimal answers. Didn't have to round or anything. Those are also the x-intercepts. Okay, and on this one, same idea. So we'll have b is 6 and a is -2. So we'll have negative of -6 plus or minus our discriminant, all divided by 2 times a, which is -2. Okay, so we have 6 and square root of 44. So we just have to estimate that. It's somewhere between square root of 36, which is 6, and square root of 49, right, which is 7. So square root of 44 is pretty close to 49, so let's just call that like 7.7. And if you have a calculator, you can get that a little more precise. So we're going to do 7.7 and divide by -4. So 6 plus 7.7, right, that's going to be 13.7 divided by -4. And then we have 6 minus 7.7, so that's -1.7 divided by -4. And you can put those in calculators and get the more approximate answer there. Okay. Let's see here. All right, so calculator. So we'll do 13.7 divided by 4. All right, so we get about 3.4 here, negative 3.4. And you see how it's this long decimal, you know, that's why we're irrational. Anytime we have to do like square root of 44, it means our answer is irrational. Then we do 1.7 and divide that by 4, and we'll get 0.4. Okay. 0.4, 4/10. So those are two approximated x-intercepts. All right, a lot of work to do on this one. Number 11. Okay, so what are possible factors? Now, remember factoring from our first two reviews, so let's just go through and factor this. Okay, so remember a times c goes on top, so this time it's going to be -12. What multiplies a -12 and adds to -4. Okay, so you go through some of the factors. Kind of helps that I have some here. It might help you out a little bit. So we have, let's see here, how about 6 and 2, with the 6 being negative, that multiplies the -12 and adds to -4. Now you might be tempted just to say that, oh, it's going to be x minus 6 and x plus 2, but if you check that and you multiply this back together, right, you'll only get x squared. You don't get 3x squared. And if you multiply the last, you get -12. You don't get -4. So we don't want to just take these numbers and just put them in here. So whenever there's a number coefficient over here other than 1, we have to kind of do a more elaborate process using these two numbers. We're still going to use them, but we have to put them in there. So what we're going to do is we're going to replace this -4 and we're going to put in -6 plus 2. So I'm going to have 3x squared, right? And instead of the -4, I'm going to put -6x plus 2x, which equals the -4, and then here, put the -4. And then I'm going to do GCFs of these two, find the GCF of these two, and find the GCF of these two. So what goes into 3 and 6? That's 3, and they also have an x, so I'll take out an x as well. Okay. And what goes into 2 and 4? Well, that you can take out a 2, right? +2. And then what should happen is when you do this, is you should get the same thing for both of these. So if you take out a 3 from here and here, you'll get an x. If you take out a 3 from here, you'll get a 2. If you take out a 2 from here, you'll get an x. If you take out a 2 from here, you get a 2. So you see how you get the same thing here. So my two factors are x minus 2 and then 3x plus 2. Now there's also a box method we did a little bit as well that will give you the same answer. Okay, so we're going to do both methods. And it's basically the same thing, is that we have our box and we have these two parts. Right, and then we took what we got from the x, which was the -6 and the +2. And we just did the GCFs here. So instead of doing all in one big row, we just did GCFs here. So same idea. What could you take out of 3x squared and -6x? And it's still the 3x that we took out here. Same thing. And then what can we take out of x2x minus 4? Right? And we still can just take out a 2. And then we can do the same thing with the columns, and we'll end up with x and -2. So you see the two factors come out to be the same. 3x plus 2 and x minus 2. Just two ways of doing the same thing, and then you can answer the questions right here. So we have yes for x minus 2, yes for 3x plus 2, and then we'll have no for everything else. Okay, so one thing that would help is to know that you're only going to have two factors, so you're only going to circle two yeses, everything else is no. Okay? All right, lastly, the triangle below has an area. Okay, get area by multiplying. So it's almost the same question, just worded a little different. Let's go ahead and factor this and just see which one of these is a factor. That's what it's asking, right? So basically the same thing we just did, only there's the a value is 1, so it's going to be a little faster. So just what multiplies to 16 and adds a negative 10, right? We'll get, let's see here, 8 and 2, looks like, right? And they're both negative. So negative 8 times negative 2 is positive 16, and negative 8 minus 2 is negative 10. And now, since there was just a 1 here, we do not have to go through all this extra process, okay? Since there's just a 1 as a coefficient for a, we can just go straight to, yeah, it's b minus 2 and b minus 8. Right? So we'll go with D. So there's going to be some questions that have multiple choice with one answer, like here, it's just there's one answer, right? We didn't have the b minus 2 as an answer here. And there's going to be some questions that have both, and you're going to have to say yes or no for each one. Okay, just make sure you actually circle or select, bubble in, yes or no for each one. Don't just bubble in the yeses and leave the no's blank, because you'll get a point for knowing that these are no's just as much as you'll get credit for knowing that this is a yes. Okay, so that is the end of this review, a little bit longer. So it's going to take some extra practice with the quadratic formula and completing the square. Easiest thing to do is to take out your reviews that we did for the test and see your own handwriting on how you did this before, and it'll really help you remember. If you just try to, force it out now without reviewing first, it might be very difficult. Okay, but in either case, you want to make sure you can do this entire review from beginning to end by yourself with no help and get 100%. You might have to do it several times, but whatever it takes to get it done, and you'll be rewarded with some good scores later on. Okay, good luck.